Hello. So in the last few classes we have seen what is the absolute extrema in a closed interval AB. Then we have seen what is absolute extrema in the intervals of the form minus infinity to infinity. And in today's class we will look at the behavior in an interval of the form open interval A to B. So open interval A to B. So one of the n can be infinite. So you can have interval of the form minus infinity to B and A to infinity. So the same result will apply for those type of intervals also. So we will see what is the absolute extrema on open intervals. So we have open interval of the form AB, and then the same conclusions will hold for minus infinity to B and A to plus infinity. So let us look at the behavior of the function. So when you have a function defined in an interval of the form open interval AB, so these are the four different cases of the limits. So you can have limit x tends to a plus f of x, so both can be infinity. So as x approaches to a, function can approach to plus infinity, and as x approaches to b, function can again approach to infinity. So here this will be the form of the graph. So function infinity like approach area. So here it will not have a maximum കാരണം ഫംഗ്ഷന്റെ ഹയസ്റ്റ് വാല്യൂ എന്ന് പറയുന്നത് ഇൻഫിനിറ്റിയിലേക്കാണ് പോകുന്നത്. അതുകൊണ്ട് ഫംഗ്ഷന് absolute maximum ഉണ്ടാവില്ല, and there can be an absolute minimum. So function has an absolute maximum, has an absolute minimum in this case, but there is no absolute maximum. And in the same way random minus infinity ആകുമ്പോൾ, so when you take limit x tends to a plus f of x, so if that is minus infinity, and limit x tends to b minus f of x is also minus infinity. So the function approaches to, so function decreases indefinitely to minus infinity. അപ്പോൾ ഫംഗ്ഷന്റെ മിനിമം വാല്യൂ ഉണ്ടാവില്ല കാരണം ഫംഗ്ഷൻ മൈനസ് ഇൻഫിനിറ്റിയിലേക്കാണ് പോകുന്നത്. So it can have a maximum value. So if this is a behavior in the open interval AB, then the function has an absolute maximum and there is no minimum. And the next behavior is when you have the limit both plus infinity minus infinity വരുന്ന കേസ്. So here limit x tends to a plus f of x is minus infinity, and limit x tends to b minus f of x is plus infinity. So you can see that function goes to both infinity and minus infinity. So function is increasing to an indefinite value and also decreasing to an indefinite value in the given interval. So our case it will neither have a maximum nor have an absolute maximum and an absolute minimum. The last case is also similar. Limit x tends to a plus f of x is infinity, and limit x tends to b minus f of x is minus infinity. From here also function goes to both ends, so therefore it does not have an absolute maximum and an absolute minimum. So let us look at an example and let us see the behavior of the function. So determine whether the function f of x equal to 1 by x square minus x has any absolute extrema on the interval 0 to 1. If so, find them and state where they occur. So here, so first of all, you have an interval of the form open interval AB. So A is 0 and B is 1. So first what we'll do is we'll find the limits. So limit x tends to 0 plus f of x and limit x tends to 1 minus f of x. So evaluate both the limits. Your denominator is x into x minus 1. So you can see that the roots are 0 and 1. So at 0 and 1 the denominator is 0. So when you take limit x tends to 0 plus, so this is a so here this is negative value, x minus 1 negative ആവും, 0 plus വരുമ്പോൾ, so therefore you are getting minus infinity. X ന്റെ value positive ആയിരിക്കും when you have 0 plus, and x minus 1 is going to be negative, so you will get minus infinity. And when you take limit x tends to minus 1, 1 minus 1 by x square minus 1. So you have limit x tends to 1 minus 1 by x into x minus 1. Again, x in the value positive when you take the limit, and this is going to be negative. So you are again getting minus infinity. So function has limiting value both minus infinity. Random minus infinity varumbo you can have no absolute minimum. Minimum undavilla, and there will be an absolute maximum. Now for finding the absolute maximum, find f dash of x, critical point kandupidikka. Appam end points lalla extrema occur cheyunnu. So the extrema is going to occur at the critical points. So find out f dash of x. So f dash of x will be, so when you take the derivative you will get minus 2x minus 1 by x square minus x whole square. So f dash of x equal to 0 gives x equal to 1 by 2. So therefore the absolute maximum occurs at x equal to 1 by 2. So that is the absolute maximum, and the absolute maximum value is minus 4. Now next we look at absolute extrema of functions with one relative extrema. So here we are given a continuous function that has exactly one relative extrema. Now the interval, it can be either a finite interval or an infinite interval. So our function, that's a continuous function, and the function either has a relative maximum or a relative minimum. So it has one relative extremum, and it occurs in, and the function is defined over a finite interval, or that can be an infinite interval. And now we can say that now one relative extremum that will become an absolute extremum. So that must be an absolute extremum. So if it has one relative maximum, that relative maximum must be the absolute maximum. And a relative minimum, that must be the relative minimum. So we will see how does that come. Okay. So let us suppose that f has a relative maximum at x0 in an interval, and that is the only relative extrema of f on that interval. So the function has a single extremum. That means either a maximum or either a single minimum. One extrema. So let us say that it is a maximum. Now if your function is such that it has another, so here x0 is a relative maximum. Appo namakku prove cheyendadana f of x0 absolute maximum aanu. Ini suppose f of x0 is not an absolute maximum. If f of x0 absolute maximum allengil, there must be another absolute maximum. Okay. So there an absolute maximum undavanengil, the function must approach a greater value. Ini x0 ennu parayunna point oru maximum ayadonde function must change from increasing to decreasing. Appo function the value താഴേക്ക് പോവാണ്. അപ്പോൾ താഴേക്ക് പോയി കഴിഞ്ഞിട്ട് അത് നമ്മുടെ function again continuous function ആണ്. അപ്പോൾ എനിക്ക് വേറൊരു maximum ഉണ്ടാവണമെങ്കിൽ ഫംഗ്ഷന്റെ വാല്യൂ ഈ പറയുന്ന f of x0 ന്റെ വാല്യൂവിനെക്കാട്ടിലും വലുതാവും. അപ്പോൾ from function is decreasing here, decrease ചെയ്തു കഴിഞ്ഞ് function increase ചെയ്ത് പോകണം. So when the function changes from decreasing to increasing, again you are going to get a second maximum, but you have said that there is only a single relative extrema. So if there has to be, appo idu absolute maximum alla ennundengil വേറൊരു absolute maximum value ഉണ്ടാവണം. അങ്ങനെ ഒരു absolute maximum value വരണമെങ്കിൽ you will have a second relative extrema. So which is not possible because there must be only a single extrema. So, if f of x naught is not the absolute maximum in the interval, then the graph has to make an upward turn somewhere on the interval to rise above f of x naught. But this cannot happen because in the process of making an upward turn, it will produce a second relative extrema. So, this is not possible since there is only a single extremum. So, therefore, f of x naught has to be the absolute maximum value. So, the relative extremum will become the absolute maximum. The same thing applies in the case of minimum also. So, there minimum varanamengil very maximum attain cheyidittu maathre adutha minimumthilekku varan pattullu. So, therefore it will again have a so minimum point undengil minimum point will be again the absolute minimum. So, you can summarize this as a theorem. So, if f is continuous and has exactly one relative extremum on the interval, say at x naught, then if f has a relative minimum at x naught, then f of x naught is the absolute minimum on the interval. Otherwise, if f has a relative maximum at x naught, then f of x naught is the absolute maximum of f in that interval. So, let us see an example. So, find the absolute extrema if any of the function f of x equal to e raised to x cube minus 3x square on the interval 0 to infinity. So, let us first find the limits of the function. So, limit x tends to infinity, f of x will be, so the highest degree term is x cube. So, x cube minus 3x square and value infinity almost x tends to infinity. Again, e raised to infinity is infinity. So, limit x tends to infinity, f of x is infinity. So, function value infinite avunonda absolute maximum illa. So, now we need to look at whether there is an absolute minimum or not. Now, limit x tends to 0, f of x is e raised to 0 varum, e raised to 0 is 1. So, now let us look at the critical values. So, f dash കണ്ടുപിടിക്കുക, f dash കണ്ടുപിടിക്കുമ്പോൾ critical values f dash equal to 0 എടുക്കുമ്പോൾ you will get 3x into x minus 2. So, critical values are x equal to 0 and x equal to 2. And these are the only critical points. Now, of this, only x equal to 2 is in the interval 0 to infinity. നമ്മുടെ critical points നമുക്ക് കിട്ടിയ x equal to 0 and x equal to 2 ആണ്. And x equal to 0 does not lie in your domain. So, there is only one critical point which is lying in the interval. So, that must be an absolute minimum. So, absolute minimum will occur at that point. ഇനി അത് നമുക്ക് absolute അത് relative minimum ആണെങ്കിൽ അത് absolute minimum ആയിരിക്കും. അപ്പോൾ നമുക്ക് ചെക്ക് ചെയ്യേണ്ടത് relative minimum ആണെന്ന്. So, for x equal to 2 to be relative minimum, f double dash of 2 must be greater than 0. So, let us evaluate the derivative. So, derivative എടുക്കുമ്പോൾ you will get, this will be the value of the second derivative. So, when you take f double dash of 2, you can see that f double dash of 2 is greater than 0. So, here you have a function which is defined in the open interval 0 to infinity, and there is exactly one relative minimum in that interval. So, therefore, it must be an absolute minimum by the previous theorem.